We've all seen stunning images of Saturn's rings like this, or this, or this. They are gigantic, they would just about fit between the Earth and the Moon. They seem to be perfect, but what would they look like up close? And what patterns and imperfections would we discover? Saturn's rings are made almost entirely of water ice, in clumps ranging from 1 centimetre to 10 metres across, all orbiting around the planet in unison. There's plenty of room between these clumps of ice, so up close you would easily be able to see through the rings to the other side. They are very thin, despite their immense width. They are nearly two-dimensional. A stack 100 rings high would have the same relative thickness as a sheet of paper. Nearby, they would appear to be lumps of ice with plenty of empty space, but looking out into the distance, they would blend to become a nearly perfectly flat, solid plane. These clumps are not solid lumps of ice, like icebergs, but loose agglomerations of ice particles. They will occasionally collide, either combining or disintegrating. You may have noticed these gaps in the rings. The tiny moon Pan, the size of a small city, defines the largest gap in the rings, which is about as wide as Switzerland. At a distance, there seems to be this perfect order in the rings, but Saturn's rings are where order and simplicity are peppered with disorder and chaos. The moon Pan is just the beginning. Let's read the patterns in Saturn's rings. Please like, comment and subscribe. Thanks. These strange, lopsided dash shapes are called propellers. They are areas where the normally smooth rings are disrupted. Scientists have discovered hundreds of such disturbances in the rings. What are they, and what do they tell us about the origins of the ring system? All the ice clumps orbit Saturn in the same direction. Clumps that are closer to the planet orbit quicker than those further out, as gravity diminishes with distance. This is basic orbital mechanics. Satellites close to the Earth, like the International Space Station, whip around the Earth in 90 minutes, just 400 kilometers up, whereas communication satellites, 37,000 kilometers away, take nearly 24 hours to orbit once. If you attached yourself to a random clump of ice in the middle of a ring, you would see the particles that are closer to the planet overtake you, whereas those further out would recede away behind you. If you were to puncture a large hole in the ring, it would start off circular, but as the innermost particles pull ahead of the rest, this shape would distort as the gap is stretched ahead, whereas the particles further out would fall behind you. This is the cause of this distinctive propeller shape. Large, but not too large, lumps of rock disturb the rings. Very massive rocks complicate matters as they have their own significant gravity, and smaller rocks don't disturb the rings enough to be seen. But these medium-sized Goldilocks rocks, roughly 100 meters across, are still too small to be seen, but these trails in the rings are large enough to be seen with a telescope. These rocks are known as moonlets, and they are too small and insignificant to count as true moons. Scientists obviously knew about the larger lumps of rock, or small moons, for a long time, but hadn't been able to find these smaller rocks that had been predicted. This prediction said that the rings of Saturn were created when an asteroid collided with a large moon, shattering it into fragments of varying sizes, ranging from lumps the size of small moons all the way down to the smallest clumps of rock and ice. The discovery of moonlets, indirectly through the propeller patterns, is a crucial piece of evidence for this theory of how the rings were formed. Waves are things we find in fluids. Sound waves carried by changes in air pressure, water waves carried in the water, of course. But what about the waves in the rings of Saturn? This may seem surprising, as there is a lot of empty space between the clumps of ice in the rings. It isn't that these clumps are bumping together, but the gravitational effects of moons pull on the clumps. These strange, beautiful banding patterns are density waves caused by the gravity of the moon Janus. How does it form such a pattern? Any particular circular orbit around Saturn has just one speed. Objects closer in move quicker, objects further out orbit slower. But there is always only one speed per circle around Saturn. If a quicker and a slower object revolve around the orbit in such a way that, as an example, one does 2 laps for each time the other does 1 lap, we will find that the objects regularly encounter each other. If one of these objects is close and massive enough, it will exert a gravitational force on the other, giving it a kick, a little speed boost or speed reduction. This is known as orbital resonance. The moon Janus is in resonance with parts of the ring system, orbiting once for every 2 times the clumps of ice orbit. This causes these parts of the rings to bunch up into these ribbed patterns. These waves are a few kilometers across in wavelength. Janus is only about 180 kilometers in diameter, so it doesn't have a tremendous amount of gravitational attraction. That said, it is known as a shepherd moon, of which there are a handful in number in Saturn's orbit. The clumps of ice are their flock. These shepherd moons enforce orders and patterns onto the ring with their gravity. Without shepherd moons, the rings would look far less orderly. Orbital resonance is also the reason why some of the gaps in the rings exist, as matter is kicked out of these orbits by the distant, resonant effects of other, larger moons. Mountains, clumps of matter rising far from the flat plane of the ring, can be seen through the shadows they cast. We see them on the boundaries of rings. When Galileo first witnessed the rings, he thought them to be the ears of the planet. But with further observation, these ears appeared to vanish. Suddenly Saturn had no ears. The solution to this puzzling fact was to understand just how thin the rings are. Edge on, they are practically invisible, and as the relative angle we see them from on Earth changes, the rings are able to disappear and reappear over time. Our solar system is filled with sizes too big to really comprehend: the size of the Sun, the distance to Mars. The widths of Saturn's rings are an exception, perfectly understandable, generally just a few tens of meters thick. In some parts, these mountains form, areas where the clumps of ice rise in waves of over a kilometre, casting shadows on the flat plane. The moon Daphnis is 8 kilometres across and orbits within the rings, in a track that it has cleared of ice. On the edges of the track, these mountains are caused by the gravitational pull of the moon. Daphnis doesn't quite orbit on the same plane as the rest of the rings, but orbits at a bit of a tilt, so it will rise above the rings, or below for some of the orbit. As it rises above, it pulls matter towards it, but as this matter is moving at a different rate around the rings compared to the moon, the ice will pull ahead. The gravity from the moon will diminish, causing the ice to fall back to the ring, creating these peculiar, wavy patterns. Other mountains, like these gigantic, pointy, 2.5 kilometre areas, are some of the tallest features on the rings. It is not quite known what causes these, but it's likely from ice clumps streaming past moonlets, maybe a kilometre across, and being deflected upwards, and they then fall back down, like a fountain in slow motion. One day, scientists will discover the true cause of this phenomenon, but it is truly one of the most beautiful and interesting things in the whole solar system. These are the patterns and imperfections of Saturn's rings. Thanks so much for watching.